Hi guys, today we're going to continue to say the F word, so let's do this. So in the last video we were factoring polynomials. Well, we introduced how to factor a perfect square trinomial. If I remember, I'll put a link to that video. Okay, today we're going to take a small break from factoring perfect square trinomials, and we're going to focus our energy on, you guessed it, factoring difference of squares. We're going to focus our energy on factoring some, I can't say that right, beep, blooper. Today we're going to focus our energy on factoring sum or difference of cubes and difference of squares. So this is like the rundown of how to approach factoring. Regardless of what technique to use, whether you use the ones that we do in class or ones that you picked up along the way, the prerequisite step is always to watch out for common factors, or GCF. If there's one, factor it from the expression. Now, what if you have a binomial, two-term expression? If you have a binomial and there's a minus sign in the middle, we have two possible options. One, we could have a difference of squares, or we could have a difference of cubes. Okay, some of these problems could get ugly really quick, and depending on your choices, you are not going to be able to factor completely by using conventional techniques. So this is my recommendations. Binomial minus, first check to see if you have a difference of squares. Okay, if you do, handle it, and if you don't, then then see if you have a difference of cubes. So first this one and then that one. Okay, so the difference of squares, how does that work? Let me go ahead and zoom that in. Okay, if you're subtracting two squared terms, if this is your question, this is your answer. A plus B times its conjugate, or in English, A plus B times A minus B. So this is just the multiplication shortcut but backwards. Cool. Now, what if you have a binomial minus and you don't have a difference of squares? Well, check it out. If you don't have a difference of squares, then check to see if you have difference of cubes. Why do we say difference of cubes? We say difference of cubes because we're subtracting two cubic terms. Okay, so if this is your question, this is your answer. There's no way around it. For the difference of cubes, you're just gonna have to put it in the formula. There's not like a easy, nice way of doing it. Okay, cool. Now, what if you have a binomial plus? Okay, if you have a binomial plus, so like a binomial with the plus in the middle, you don't have two options. We're gonna go straight to sum of cubes. Why straight to sum of cubes? Well, that's because the difference, that's because the sum of squares is not factorable. Okay, so if this is your question, that's your answer. So what I want to get at with the cubes, whether you have a sum or a minus, a sum or a difference, the answers are kind of the same. Okay, they're both a, b, and then the trinomial factor, a squared, ab, b squared. As a student, I would always put a 2 in front of the ab because I'm so used to the multiplication shortcut, square of a binomial. But no, this is your question, that's your answer. So for the binomial factor, it's a, b, and for the trinomial factor, it's a squared, AB, B squared. So for the signs, the first one is the same, the second one is opposite, and the third one, no matter if you're adding or no matter if you have a sum or difference of cubes, it's always going to be positive. So same, opposite, always positive. I have a colleague that has a really nice song, but I'm not a singer, so yeah, that's it. You just have to stick with soap. Okay, cool. Now, what if you have a trinomial? That's what we discussed in the earlier video, so I'm going to stop right there. Okay, so let's go ahead and knock out these fun problems. So we have a total of 9 problems. Let's see how long it takes us to knock them out. Okay, so we have problem A. We have x squared minus 100. X squared minus 100. Okay, prerequisite step, watch out for common factors. There's no GCF to yank out, so we're good. So I'm like, okay, binomial minus, I have two options. Option number 1, do I have a difference of squares? Okay, question mark. I like to speak to myself. Do I have a difference of squares? I'm going to assume that we have, and if not, then we go straight to difference of cubes. Okay, I don't really see it, so I'm going to do the mold. Do I have something squared minus something squared? I think I do. Why? X squared is a perfect square because it's the square of x. 100 is a perfect square because it's the square of 10. So to answer my question, am I subtracting two square terms? And the answer is yes. So let me remind myself of the formula, okay? If we are subtracting a difference of squares of the form a squared minus b squared, if this is your question, then this is your answer. A plus b times its conjugate. A plus b times a minus b. Our first base is x, so that's our a. Our second base is 10, that's our b. So again, to quickly factor a difference of squares, if this is your question, then this will be our answer. So this should factor to x plus 10 times its conjugate of x minus 10. What do we do thereafter? Nothing. Okay, we already watched out for common factors, but in the event that we overlooked it, we check it now. There's no GCF to yank out, so we're good. Okay, let's go ahead and knock out problem B. Problem B, where am I? So problem B, we have 121 x squared minus 16 y squared. Okay, so again, prerequisite step, watch out for common factors. We don't have any. Binomial minus, you have two options, difference of squares or difference of cubes. Love yourself, always aim for the square and then the cube. You will regret it if you go the other way around. So I'm going to ask myself, do I have a difference of squares? I'm not going to write down the formula again, but I will always I will always write down my question. So I don't know. So let's go ahead and see if we fit the mold. Am I really subtracting two square terms? 121x squared is a perfect square because that's the square of 11 times x, or in short, 11x. 16y squared is a perfect square because it's the square of 4 times y, or 4y. So to answer my question, am I subtracting two square terms? I sure am. Okay, or I guess I should put yes. So formula wise, if this is our question, then this is our answer. Our first base is 11x. Our second base, I can't do the upside down brace. Our second base is 4y, and if we are factoring a difference of squares of the form a squared minus b squared, then our answer will be a plus b times its conjugate. It will be a plus b times a minus b. So in this case, it will be 11x plus 4y multiplied by 11x minus 4y. Okay, problem C. Problem C, where am I? We have x squared minus 9a squared. Okay, x squared minus 9a squared. Prerequisite step, it's always going to be the same speech. Do we have a common factor to yank out? The answer is no. How many terms do we have? 2. Okay, what's the sign? Minus. Okay, binomial minus, we ask ourselves, do we have a difference of squares? And if the answer is no, then we jump straight to like difference of cubes. So you know the drill. Let's see if we have the mold. Do we have something squared minus something squared? This is a little bit more spicier for me. X squared is a perfect square because it's the square of x. Y squared is a perfect square because it's the square of y. Okay, so let me check it. Xy to the second power, xy times xy is going to give us x squared, y squared. That's exactly what we have. Okay, so we got perfect square in the beginning. Now let's see if we have a perfect square at the end. 9a squared is a perfect square because it's the square of 3 times a, or like 3a altogether. So to not let myself be hanging, am I subtracting two square terms? Do we have a difference of squares? And the answer is yes. Okay, formula wise, okay, if this is our question, then this will be our answer. So if we are factoring a difference of squares of the form a squared minus b squared, then this should factor to a plus b times its conjugate. So it will be xy plus 3a, a plus b times a minus b. So xy plus 3a multiplied by xy minus 3y multiplied by xy minus 3a. Someone said, how do we check our answer? Same way we did from like day one. Multiply it back out and can confirm you get the original expression. Cool. So we're doing 9 problems. That's number 3. We got a few more to go, so bear with me. Okay. Problem D. Let me get this out of the way. Okay. Problem D. Where am I? Okay. Problem D. We have 81 times m to the 10th power minus 49 z squared. Fantastic. Okay, so the question that I'm gonna ask myself is this: prerequisite step, do we have a common factor? And the answer is no, because the terms don't have any factors in common other than 1. How many terms do we have? 2. Okay, what's the sign? Minus. Okay, so we're gonna go straight to difference of squares, and if that doesn't work, then difference of cube. So binomial minus difference of squares. Cool. Alright, so I don't want you thinking that everything is a difference of squares, but my new take on the way I'm doing these problems is like I'll do them in groups, so you get the habit, or you have a better sense of how to practice it, and then I'll move on to another chunk. Alright, so let's do this. So do we have a difference of squares? To tell you the truth, I have no idea. The numbers, yeah, but what's throwing me off, it's the variables. So 81, I know that's a perfect square because it's the square of 9. M to the 10th, I really don't recognize that as a perfect square, but let me tell you how we're gonna do it. We're pretty much gonna use the power rule in reverse. So let me go ahead and use like a thinking area. Okay, so the power rule for exponent says this: if you have a factor and you're raising it to some power, you're gonna keep the base and then multiply the exponents. Okay, so we're gonna use the power rule in reverse. Instead of multiplying the exponents, we're gonna divide the exponents, and this is how it's gonna go down. We're gonna take the current exponent divided by the desired exponent of 2, and if that gives us an integer, then guess what? We do have a perfect square. If that doesn't give us an integer, then we do not have a perfect square. But in this case, 10 divided by 2 is 5, clean number 5, so perfect square. Okay, so m to the 10th is a perfect square because it's the square of m to the 5th. Okay, so the first term is a perfect square because it's the square of this. 49z squared is a perfect square because it's the square of 7 times z, or 7z. So if we have a difference of squares of the form a squared minus b squared, then that will always factor to a plus b times a minus b. So this will factor to a plus b times a minus b. Okay, well, if I say it correctly, 9 times m to the 5th plus 7z multiplied by its conjugate. Cool, fantastic. Okay, so that's enough of that. We can do 20 more, but you don't have time for that. Alright, so problem E. Okay, I've lost track how many problems we're doing, but remember, we're doing 9 overall. Problem E, we have 1000 plus x cubed. So am I having a moment? Of course I am. Okay, prerequisite step, watch out for common factors. There aren't any. Binomial plus. If we have binomial plus, we're going to go straight to sum of cubes. Why not sum of squares? Well, that's because the sum of squares is not factorable. It's not because the book said so, it's just not factorable. Okay, cool. This is new to me. First, let me see if we do have a sum of cubes before I try to remember the formula. Okay, so let's do the mold. Do we have something cubed plus something cubed? Okay, I'm gonna go with what I feel more comfortable with, which is x. Okay, x cubed is a perfect cube because it's the cube of x. Cool. If one of these terms is a perfect cube, chances are the other term is also a perfect cube. So if you recognize 1,000 as a perfect cube, more power to you, but I don't. So this is how I do it. 1 to the third, 2 to the third, 3 to the third, 4 to the third, all the way until I get my 1,000. And when I get to 10 to the third, we get 1,000. Okay, so 1,000 is a perfect cube because it is the cube of 10. So to answer my question, do I have a sum of cubes? Absolutely. Okay, let me go ahead, write down the formula. So we have, if we have a sum of cubes, if this is our question, then this will be our answer. Let me put the terms first and the signs later. So we have a, b for the binomial, and then for the trinomial, a squared, ab is not 2ab, that's for multiplication. A squared, ab, b squared. Okay, for the signs, I forget. So we're going to bust out the soap. Same, opposite, always positive. We got a plus sign. Same, opposite, always positive. What do we do after we put it into the formula? Nothing. Okay, that's our answer. Can you break it down? No, because then the formula would have been broken down. So let's do this. Let's write down our problem. I'm going to write this over again. Okay, so we have 10 cubed plus, where am I? X cubed. Why do I put it in parentheses? Because it helps me like to identify the base. The first base is 10, so that's our A. Our second base is X, so that's our B. So if this is our question, then this will be the answer. Okay, A plus B. So it'll be 10 plus X and then for the trinomial factor, the first term is of the form a squared. So I'm going to take my a and square it. 10 times 10, 100. Keep plugging it in. Keep plugging it in. Minus ab. Product of a and b, namely 10 and x, will give us 10x. Always positive, b squared. Value of b is x, and when we square it, that will give us x squared. Cool. What do we do thereafter? Nothing. Okay, we watched out for common factors from the start, and if this is our question, that's our answer. You should not be able to break this down because that's our answer. Cool. Where are we at? I'm not quite sure, but we're doing 9. So let's go ahead and do another one. F. Problem F, we have 8x cubed minus 125. Okay, so let's do this. Prerequisite step, watch out for common factors. There's no GCF to yank out. How many terms do we have? 2. Binomial. What's the sign? Minus. Binomial minus. Let's ask ourselves, do we have a difference of squares? 8 is not a perfect square, so that's it. That kind of makes me sad, okay? Because if we don't have a difference of squares, then we're going to have to see if we have a difference of cubes. Okay, so let's see if we have a difference of cubes, and then we'll worry about the formula. So do we fit the mold? Something cubed minus something cubed. I'm going to focus on 125. 125 is something that I work with a lot, so I do recognize it as a perfect cube. But what if you don't work with it a lot? Then just start from 1. 1 to the third, 2 to the third, 3 to the third. And once you get to 5 to the third, you'll be like, okay, that simplifies to 125. 8, is that a perfect cube? Yeah, because it comes from 2 to the third, okay, or 2. X cubed is a perfect cube because it's the cube of x. So altogether, 8x cubed is a perfect cube because it's the cube of 2x. So if I ask myself a question, I need to answer it. So let's go ahead and write down the formula. So if we have a difference of cubes, if this is our question, then this will be our answer. AB, and then for the trinomial factor, a squared, AB, B squared, and I always forget the sign, so let's go ahead and bust out the soap. And we have same, opposite, always positive. So let's do this. The first sign is the same, so minus. The second one is opposite, plus. And the third one is always opposite. Okay, so let me go ahead and write my problem again in the molds, because if I write 8x cubed minus 125, that's not going to help me to identify A and B. Okay, our first base is 2x, that's our A. Our second base is 5, that's our B. So let's do this. We know what the answer should look like. Okay, so the binomial factor should be of the form A minus B. So be 2x minus 5. This is in my way, so I'm going to look at this. The trinomial factor should start off with a squared. So we're going to take a and square it. 2x times 2x will give us 4x squared. Plus. Middle term should be of the form AB. Product of 2x and 5 will give us 10x. Always positive, b squared, and the square of 5 is 25. Remember, this is our answer, so this trinomial we shouldn't be able to break it down. Alright, G. Oh, that means I should wake up. Okay, G, where am I? We have 64x to the 7th minus 27 xy cubed. Alright, fantastic. Okay, prerequisite step is to watch out for common factors. Looking at the coefficients, I'm going to focus on 27. Factors of 27, 1, 3 doesn't go into 64, so that's it. Okay, for the variables, we have 7 x's, 1 x, we could factor out an x. So let's go ahead and show the world what we're left with when we factor out an x. First term over common factor, that will leave us with 64x to the 6 minus. Second term over common factor, that will leave us with 27y cubed. So we have factored, but the question is, can we factor more? And you know the drill. We are going to assume that we can until we realize that we cannot. Okay, so let's do this. Binomial minus. So the question is, do we have a difference of squares? I really hope so. And if not, then do we have a difference of cubes? Okay, so difference of squares. Okay, so 64 is a perfect square, and x to the 6 can be written as a perfect square because 6 divided by 2 is a clean number. But check it out. 27 is not a perfect square, so unfortunately we do not have a difference of squares. Okay, so then I'm gonna ask myself, it's okay, do we have a difference of cubes? Okay, so again, I'm gonna assume that we do until I realize we do not. Okay, so let me go ahead and do the mold. Are we subtracting 2 cubic terms? Okay, 64, I know it's a perfect square, 8 squared. I don't recognize it as a perfect cube, so I'm just going to start from 1. 1 to the third, 2 to the third, 3 to the third, 4 to the third. 4 to the third is our winner. Okay, 4 to the third power gives us 64. So 64 is a perfect cube. X to the 6, is it a perfect cube? Again, you're going to have to use the power rule in reverse. Divide the exponents and hopefully you get an integer. 6 divided by 3 is 2. So that means that x to the 6 is a perfect cube because it's the cube of x squared. 1 perfect cube down, 1 more to go. 27 is a perfect cube because it's the cube of 3. Y cubed is a perfect cube because it's the cube of y. So to answer my question, do we have difference of cubes? The answer is yes. It's a bittersweet moment because that means I have to do it. So let me go ahead and bring down the times x. So if this is our question, what will be the answer? Let me write down the formula on the side because I got a common factor over here. So we got a cubed minus b cubed. That should be a minus b. A squared plus ab plus b squared. Oh, sorry, I forgot to write down, so my bad. Okay, cool. So let's identify a and b. So the first base is a, so that's our 4x squared. The second base is b, so that's our 3y. So let's do this. So we have, for the binomial factor, a minus b. So be 4x squared minus 3y. Times the trinomial factor of a squared plus ab plus b squared. So let's do this. First term is a squared. So we're going to take a and square it. 4x squared times 4x squared will give us 16x to the fourth. Again, the formula is the answer, plus ab. Product of 4x squared and 3y will give you 12x squared y. Always positive, b squared, and the square of 3y, 3y times 3y will give you 9y squared. Just don't forget to bring down your common factor. Cool. Alright, so we could be done, but since I like you a little, then we're gonna go ahead and do 2 more to do our 9 problems. Okay, cool. Yeah. Problem H. So problem H, we have 2 times y to the 8th minus 162. Okay, 2 times y to the 8th minus 162. First things first, watch out for common factors. And in this case, we have a common factor of 2. When we factor it, that will leave us with y to the 8th minus 81. Fantastic. Binomial minus, let's ask ourselves, do we have a difference of squares? And if not, then we'll see if we have difference of cubes. Y to the 8th, can we write it as a perfect square? Yeah, because 8 divided by 2 is a clean number. Okay, cool. And 81 is a perfect square. So yeah, we will have a difference of squares. Okay, so y to the 8th, 8 divided by desired exponent is 4. So y to the 8th is a perfect square because it's the square of y to the 4th. 81 is a perfect square because it's the square of 9. So to answer my question, do we have difference of squares? We sure do. So gentle reminder, friendly reminder, if we have difference of squares, if this is your question, then this will be your answer. A plus b times a minus b. The first base is y to the 4th, so that's our a. The second base is 9, so that's our b. Let's go ahead and write down the answer. So if we are subtracting a difference of squares of the form a squared minus b squared, then your answer should be a plus b. So we have a plus b times a minus b. And don't forget to bring down your common factor. Cool, so we're almost done. Check it out. Unlike the other problems, the degree of this binomial is not 1. If the degree is not 1, then you gotta see, can you break it down more? Okay, so we got binomial plus. I want to know, do we have a sum of cubes? The answer is no, because 9 is not a perfect cube. Who cares about this one? So done with this. Degree is not 1, so we have to see, can we break it down more? Binomial minus. Do we have difference of squares? 9 is a perfect square. 4 divided by 2 is a clean number. So yeah, we do have difference of squares. So let me do the mold. Do we have something squared minus something squared? 4 divided by 2 is 2. So y to the 4th is a perfect square because it's the square of y squared. 9 is a perfect square because you're cool like that. Okay, because it's the square of 3. So again, if this is our question, that's our answer. The first base is y squared and the second base is b. Okay, so the y to the fourth minus 9 should factor to y squared plus 3 times its conjugate. Y squared plus 3 times its conjugate. Okay, that's like the ugliest 3 ever. Okay, let's bring down the rest of the problem. We have a binomial of y to the fourth plus 9, and then the binomial of times 2. Fantastic. But I learned my lesson. Anytime the degree is more than 1, we have to see if we could break it down more. We talked about the first binomial. Let's look at the next one. The degree is more than 1, so we gotta see if we could break it down. Binomial plus, our only get out a ticket is sum of cubes, and we don't have sum of cubes. Binomial minus, do we have difference of squares? No. Do we have difference of cubes? No. So like we're done finally. Fantastic. So for our ninth and final problem, okay, so if you made it this far, there's really no need to take a break. You might as well just write it out with me. Okay, so let's do this. So we are trained to clear grouping symbols, but for this problem, if you clear grouping symbols, it's gonna get a lot uglier really quick. Okay, so let's go ahead and do this. Oh, I don't like how we have bleed through from the back. This is why we write only on one side. Remind me not to write on both sides anymore. Yeah, okay, so let's do this. So in this case, we got two things that are being subtracted. So although we don't have a binomial, we do have a binomial-like expression because we got two things. So I'm gonna ask myself, binomial minus, okay, do we have a difference of squares? No idea. At the end we have something squared, okay, so we do have a perfect square right there. The question is the first term also a perfect square? So again, you use the power rule in reverse. 4 divided by 2 gives you a clean number, okay? So x to the fourth is a perfect square because it's the square of x squared. For the rest, the second part of this problem, we're just going to copy the binomial as is. So to answer the question, do we have a difference of two squared terms? Yeah, okay. So if this is our question, then this is our answer. A plus b times a minus b. Our first base is x squared. Our second base is that binomial. Okay, base, power, base, power. So let's go ahead, factor. Okay, a squared minus b squared. Answer should be a plus b times a minus b. So be x squared plus the next base times x squared minus the second base. But bear in mind that the subtraction sign affects the value of everything. Okay, so let's go ahead, wrap it up. Let's go ahead, clean this. So let's go ahead and write down what we have. If you see me stuttering, it's because I have a little person next to me. Okay, my son woke up. Alright, so let's do this. Whenever you have a polynomial and the degree is more than 1, we gotta see if we can factor. We got a trinomial. The leading coefficient is 1. So since the leading coefficient is 1, and if it's factorable, we really don't have to use the AC method. Okay, let's see if the X game has a solution before I'm quick to throw down parentheses. Okay, so corresponding X game, we want factors of C that add up to B, factors of 1 that add up to 2. Okay, factors of C that add up to B. Okay, factors of 1 that add up to 2. Oh, look at you. There's a winner. Okay, factors of 1 that add up to 2 are 1 and itself. So the moral of the story is this. If the X game has a solution, then the trinomial is factorable. So let's do this. So this should factor to x plus 1 times x plus 1. So we have talked about how to factor trinomials whose leading coefficient is 1. I'll try to remember to link up the video if I remember. Alright, next expression. Let's go ahead, distribute the subtraction sign. So we're going to go ahead, add the opposite, distribute the negative. No one will know how you dished it out. Opposite of a positive term is a negative term. Opposite of a positive term is a negative term. Sorry, I forgot to write it down. I learned my lesson. If the degree is more than 1, then I gotta ask myself, can I break it down more? Since the leading coefficient is 1, if it's factorable, we wouldn't have to do the x game. We would just go ahead, throw down parentheses, and then fill in the binomial factors. So let's see if it's factorable. We would want factors of c that add up to b, factors of -1 that add up to -2. Unfortunately, or maybe fortunately, we don't have integer factors that multiply to -1 at the same time add up to -2. So what I want to get at, that the x game has no solution. X game has no solution. That says no solution. Pretend you can read that. So if the x game has no solution, then that means that the trinomial is not factorable. Let's look at our new factors. Binomial, degree is 1, no GCF, same speech. So this will be our answer. Okay, if you look at the back of the book, you know their deal. They like to use exponents for repeated factors. I really don't care. It's really a personal choice. Okay guys, we did it. We have one more video to wrap up the this little unit. Thanks.